Good afternoon, fellow alien watchers, and welcome back to another angry alien update. Once again, 3I Atlas has found its way into the headlines, continuing to behave in ways that are, frankly, difficult to ignore. We're still imaging it, still studying it, still breaking down what we're seeing. And at this point, I can honestly say I'm no longer shocked when this object reveals yet another bizarre trait. Given how many strange behaviors we've already documented, any new anomaly should almost feel routine by now. And yet, there's still a part of me, a quiet, stubborn part, that wants to believe this thing is ultimately natural. Strange, yes. Unusual, absolutely. But still a natural object that should, eventually, begin acting like one. A genuine comet or asteroid, after all, should calm down as it moves away from the sun. Its activity should decrease. Its features should fade. Solar heating weakens with distance, meaning sublimation and sun-driven effects should become less visible, not more. That's why what we're seeing now is so troubling. Instead of diminishing activity, we're witnessing new and increasingly dramatic developments, most notably, a far more prominent anti-tail than anything previously observed. If this feature is natural, it should only appear when solar heating drives unusually large particles sunward for perhaps a few 100,000 kilometers. And even then, as the object recedes from the sun, that anti-tail should weaken. A normal dust or ion tail should dominate instead. But that's not what's happening. What we're actually observing are jets, odd, persistent structures, becoming clearer, sharper, and more pronounced. The anti-tail, in particular, has now become one of the most dominant features of 3I Atlas. Even without specialized filters, the coma itself continues to point toward the sun, something it absolutely should not be doing at this stage of its journey. So in this video, we're going to break down how these features are being revealed. I haven't spent much time explaining the imaging techniques used in previous 3 Atlas videos, but it's important to understand them, especially when you compare 3 Atlas to other comets observed using the same methods. When you do, just how strange this object is becomes immediately obvious. After that, we'll take a deeper look at the newest features emerging as 3 Atlas continues its exit from the solar system, seemingly intent on delivering one bizarre surprise after another. It's hard to believe that nearly 36 years have passed since the Hubble Space Telescope launched on April 24, 1990. And despite its legendary status today, its early history was anything but smooth. Shortly after deployment, astronomers discovered a critical flaw, a tiny spherical aberration in its optics. The very first images, which were expected to surpass anything humanity had ever seen, turned out to be deeply disappointing. This was especially shocking given that such flaws rarely appear in even modest backyard telescopes, yet somehow affected NASA's flagship observatory. A corrective mission had to be launched, effectively fitting Hubble with a pair of glasses. One of those early flawed images is what you're seeing now. Since then, however, Hubble has become indispensable, unlocking countless cosmic mysteries. And comets have long been one of its specialties. Hubble can reveal details far beyond the reach of most telescopes, thanks in part to specialized processing tools, such as the Larsen-Cecchinina rotational gradient filter. This technique removes circular features from an image, allowing non-circular structures to stand out more clearly. The process works by subtracting a rotated copy of the image from the original. Circular structures like the coma remain unchanged by rotation and cancel out, while linear features, like jets, shift position and become dramatically enhanced. If the comet moves between exposures, a radial adjustment can be applied as well. In simple terms, the filter strips away the bright, symmetrical coma and exposes straight, directional features that would otherwise be hidden. For example, take Comet C/2022 E3. In the unprocessed image, you see the expected ion and dust tails. But once the filter is applied, jets emerge, striking but orderly. And importantly, every jet on a typical comet aligns with the solar wind. Apply that same filter to 3I Atlas, however, and the result is completely different. What appears instead is a massive anti-tail thrusting straight toward the sun, directly opposing the solar wind, accompanied by several additional jets pointing in conflicting directions. Some follow the solar wind, others cut across it. This is something we have never observed in any natural comet. Now that we understand how these filters work and how they reveal these hidden features, the question becomes, what is 3 Atlas doing now? The most recent Hubble image, captured on January 7, 2026, shows the antitail in extraordinary detail. Using the same Larsen-Sekanina technique, astronomers identified a triple jet structure dominated by a tightly collimated antitail extending roughly 11.6 times longer than it is wide, once again, directly defying the solar wind. Nothing like this exists anywhere else in recorded astronomy. Even more curious, the 2 secondary jets are evenly spaced in angle relative to the antitail and to each other. And instead of pointing away from the sun like normal cometary features, they sit nearly perpendicular to it, just as hinted in the very first Hubble image from July 21, 2025. The extreme collimation and dominance of the antitail are unprecedented. Given solar radiation pressure and solar wind forces, this jet should not be the largest feature. If anything, the perpendicular jets should dominate. But they don't. When Avi Loeb submitted a paper discussing this anomaly to Astrophysical Journal Letters, the response he received was blunt. I believe your results would be of rather limited interest to the astrophysics research community as a whole. That reaction is astonishing given just how unprecedented this feature is. Thankfully, other academic groups were willing to publish his work. Observations of the antitail's wobble revealed that the object's rotation axis points toward the sun within about 7 degrees, a configuration that persists as the object moves away. Combined with its alignment to the ecliptic plane, each of these geometries carries a sub% probability. Together, their likelihood drops below 0.00001. In other words, this should not be happening by chance. Even without filters, the raw imagery remains stunning. The coma itself continues to spear sunward, something no natural comet does. Avi Loeb suggests that the particles responsible must be much larger than typical comet dust, large enough to resist solar wind pressure, yet small enough to eventually be destroyed after traveling hundreds of thousands of kilometers. They are not microscopic dust or gas. They are something else entirely. Yet mainstream science and media barely acknowledge this. A BBC graphic, for example, depicts 3 Atlas traveling tail first like an ordinary comet. But that's not what it's doing. Its tail remains pointed at the sun as it moves through the solar system. Why does this discrepancy persist? Your guess is as good as mine. I hope you're still enjoying this content. I know I cover 3I Atlas frequently, but it's warranted. This object represents a singular moment in astronomical history. Nothing else observed under these conditions has behaved this way. And while the Vera Rubin Observatory has yet to detect the flood of interstellar objects we were promised, that only makes 3 Atlas more exceptional. This object passed Venus, Mars, and soon Jupiter, something no known interstellar visitor has ever done. That alone is historic. When combined with its strange behavior, it demands continued observation. The absence of obvious technosignatures doesn't rule anything out. Aliens wouldn't necessarily use narrowband radio. The possibility of a modified asteroid or comet, perhaps even carrying probes, remains open. In fact, we've identified something interesting in rover imagery following its Mars flyby, though not enough yet for a full video. We need to keep watching. And we need to keep open minds, something many astronomers struggle to do, not due to conspiracy, but because of institutional commitment. They've invested too much credibility in calling this a comet. Eventually, the data may force a reassessment. What passed through our solar system in 2025 and 2026 is extraordinary, unique, and possibly transformative. Thanks for watching. Please like and subscribe, and consider supporting the channel through Patreon or Super Chat. January is brutal for creator revenue. Every bit helps. Until next time, stay angry about space. And as always, I want to be clear about one thing. This channel isn't about certainty. It's about observation, pattern recognition, and refusing to ignore anomalies simply because they're inconvenient. Science doesn't advance by pretending strange data doesn't exist. It advances by confronting it head-on, even when the implications are uncomfortable. 3I Atlas may turn out to have a perfectly mundane explanation someday. That possibility still exists. But pretending that what we're seeing right now fits neatly into existing comet models is not skepticism, it's denial. Real skepticism demands that we question everything, including the assumptions we've already committed to. So as more data comes in, as more images are processed, and as this object continues its journey outward, we'll keep watching. We'll keep comparing. And we'll keep asking the questions that don't seem to be getting asked anywhere else. Because moments like this don't come often. Objects like this don't come often. And when something genuinely unprecedented shows up in our cosmic backyard, history has shown us one thing very clearly. Ignoring it never ends well. Thanks again for sticking with the channel, for supporting independent analysis, and for staying curious. More updates are coming very soon. Until then, stay angry about space.